Hello and welcome everyone to this coding tutorial. In this coding tutorial we are going to look at my plugin Hammer and Meizel's ModalHarmonize feature. Hammer and Meiszel is a plugin that I have released already, but while making this video it was still in a very early stage. So that's why there is no GUI but just this module down here with a few parameters. It is essentially a modal filter, a polyphonic one, and it is key tracked with MIDI inputs. So I can play some chords with it and then it will make the sound become an instrument. The modal mix parameter mixes the two different modal filters with each other. In this video we are going to be doing two things. First thing is we're going to look at how the ModalHarmonize feature works. When it's on 0%, then it is just exactly what the modal filter is like. The more you turn it up towards 100%, the more the frequency ratios of the internal resonators are in the harmonic series, which sounds more harmonic. But you can also turn it into the other direction to minus 100%, which would mean that it's maximally disharmonic. And the second thing that we are going to do in this video is we will add another parameter. The idea for the second parameter is, let's say there are a few harmonics. These are supposed to be harmonics where like the height is the magnitude of the individual harmonics, while the distance is the interval in frequency ratio. And the parameter that I will add later is to saturate all of these peaks so that they are more close to the value 1. I want to know what that sounds like. So if you want to know what that sounds like as well, you should stay tuned for that. So here we are in the processing method of my modal filter, which starts by updating the modal mix. So if any of the parameters have changed, which are the modal mix and the ModalHarmonize parameters, then I update the values and then I call setMix on the material object. The material object is the object that contains the two modal filters material. So let's check out this method. This is pretty straightforward. I'm just looping from 0 to num filters, so the amount of resonators per voice, and linearly interpolate between the magnitude of the first resonator and the second one, and that's the magnitude that is going to be used by all the filters. And I'm doing the same for the ratio. At the end, if the harmonize parameter is not 0, then I'm also looping through all of the filters, this time linearly interpolate between the current ratio and the rounded frequency ratio. And it's kind of fascinating how easy this is. This is just a bunch of linear interpolations and it has this super juicy effect on the sound. That's just fascinating. Stuff is rarely that simple when it sounds so cool. Of course, there was a lot to do to build up to this point, but still. So you might be wondering what happens next after we have updated this information. We are looping through all of the voices and we update the frequency ratios, which means that we again loop from 0 to num filters, get the frequency ratio, multiply the frequency of this voice with a frequency ratio. The frequency depends on the last note that came into this voice. Then whenever the frequency is lower than Nyquist, it can be used for a resonator. So the resonator is picked, the FC value is being calculated, and I update the cutoff frequency and update the resonator. I don't have to go into detail about the other things. This video is not so much about reproducing the whole thing. I just want you to get a feeling for some of the specific intricacies when making a plugin like this. Alright, so next up I want to find out if I can implement this saturation feature. So now we are in the parameter header. And I make a new parameter, ModalSaturate. It's not entirely decided yet if the parameter is going to be called ModalSaturate, by the way. So if you can't find this parameter in the final product, then that's the reason, because I don't know what exactly it will do to the sound. And if it does something to the sound that doesn't sound like saturation or something like that, then I will rename it, maybe. Pushback, make param, PID ModalSaturate. Starting at 0. This is also a simple normalized parameter. So now it is time to actually get this parameter in the audio processor and get its value. And we need to make sure that it is fed into the modal filter. The modal filter doesn't know yet that it wants to have this value. So we should let it know that it is an awesome value that it should not miss out on. Now the update modal mix function also needs to have information about ModalSaturate, and this if statement needs to be checking for ModalSaturate changes as well. Now next up I need to update the setMix function. So now if ModalSaturate is not 0, okay, it wants to saturate the magnitudes, which is correct, but with the function power of magnitude saturate, what would that be like? So a parameter from 0 to 1, and now x of parameter. Yeah, I mean that kinda looks like saturation, but it would be the wrong way around. It needs to be linear at 0 and saturated at the other values. So more like this. Looks kind of reasonable. Alright, perfect. Now I just need to make sure that it looks the same in the header. Nice. Alright, let's run this thing. Yeah, that's really cool. Just as I expected, saturating all of the individual harmonics of the resonators really makes the sound more colorful and more even in some way, because now all across the spectrum it produces kind of the same energy. It is actually quite similar to real saturation, but instead of adding harmonics, it just makes sure that the already existing harmonics have more energy, which is also kind of cool, maybe even better. Yeah, so I guess we could wrap up this video with, if you ever happen to make your own modal filter, you will run into a situation where it becomes extremely easy to add new features. And I'm having a really great time at the moment, because now I can just add one feature after another until I run out of ideas, and it will become so glorious. Alright everyone, see you next time.